We know that alternating current is sinusoidal in nature, right? In our previous class, in our previous lecture, we calculated the average current in full cycle and average current in half cycle, right? So we calculated average current, not RMS value, right? So the average current in full cycle is 0, and whereas the average current in half cycle is what? 2I0 upon pi, right? And its value already you know that. Today, now we are going to focus how to calculate the root mean square, right? Which is very important, and I am going to tell you the significance of a root mean square. For example, in our household circuit, in our household current, we find, suppose it is 220 volt, 50 hertz, right? 220 volt. Maybe in America it may be 120 volt, or in Europe it may be sometimes more or sometimes less, but frequency is always either it is 50 hertz or 60 hertz, right? This value, do you think it is peak value or RMS value, right? So this is RMS value, it is not the peak value. Okay, now I'm going to show you how to find out the RMS value, the root mean square in alternating current. Before going to find out the calculation, I want to tell you about root mean square. That means first we have to suppose, if it is alternating current, which is sinusoidal in nature, so then the current at any instance we write I0 sine omega t. Similarly, the EMF, the alternating EMF, which is we are writing V, some writers they are writing E, so that is same thing, you can write either V or E, right? So if the EMF is V, we can write V0 sine omega t. I0 is the peak current and V0 is the peak EMF, right? So if I at any instance is I0 sine omega t, if you want to find out I RMS or if you want to find out V RMS, the value is always I0 upon root 2. Similarly, V0 upon root 2. Okay, if you divide I0 by root 2, you can find out the RMS value. And this is the RMS value what we are getting in our household current. Now, I want to derive the expression. I'm going to derive, which is very important for AP physics and A-level physics, which is very important. I'm going to find out the derivation for you, and let us find out the derivation, right? So now, if I tell you root mean square, if you want to find out IRMS, right? First, you have to take I, yes, you have to make it square. So we are writing root mean square, that means first we have to make it square, right? Then we have to find out mean. So the mean, some writers they are writing like this, and some writers they are writing like this. Okay, generally in your book you will find this symbol, right? Then you have to find out root. Okay, so this is not the way you are going to calculate. I'm going to show you the complete expression now. So the RMS, first square, then mean, then root. Okay, so this is the root mean square. That means the RMS value is square, mean, then root. Okay, in the next step, this I, in place of I, since it is sinusoidal in nature, can I write I0 sine omega t? Answer is yes. Since it is I square, can I write I square and sine square omega t? Answer is yes. Then we have to find out its mean. Then we have to find out its square root. So the square root, can I write power half? In the previous lecture, I told you that if you want to find out average of any physical quantity, if it is depending upon time, for example, if you want to find out I average, because this symbol stands for average, if you want to find out its average, then you can write integration of I dt upon integration of dt. Okay, any physical quantity, if it is depending upon time, if it is time dependent, then if you want to find out its average, then we can write in this way. Is okay? So I'm going to write in the same way. So let me write here. So any average, if it is average of current or average of EMF, so we can write integration of I dt upon integration of dt. Okay, so now here, so can I write integration of I naught square sine square omega t upon integration of dt, right? And total, since it is square root, the power is 1 upon 2. Is it clear to all? And this integration we are going to do for the full cycle, means the time starts from 0 to t, right? So the integration range is from 0 to t, and here also 0 to t. Is it clear? So now in the next step, since I naught, it is the peak value and it is the constant value, can I bring it outside? Answer is yes. So I can write I naught square and integration of sine square omega t, sorry, I forgot dt here, dt, and starting from 0 to t, and the integration of t, is directly I can write here upon t, and completely outside it is the square root. Is it clear to all? Right? So now I want to erase this one. So this is the sinusoidal in nature, that is why I have written the graph, so I want to erase this. Now one thing you remember, in trigonometry, cos 2 theta is equal to 2 cos square theta minus 1, or 1 minus 2 sine square theta. Okay, I think you are familiar with this in trigonometry. So then if I ask you 2 sine square theta, which is equal to 1 minus cos 2 theta, right? So if I ask you sine square theta, 1 minus cos 2 theta upon 2. I think this is what we will use here for the integration. So this is not the calculation. I'm showing you how to use sine square theta in place of, how to find out this one. So since we are talking about sine square omega t, can I write 1 minus cos 2 omega t upon 2? Is it clear to all? Sine square omega t, which is equal to 1 minus cos 2 omega t upon 2, right? So the same thing I'm going to write now. Okay, so right now I'm writing, so I naught square upon t, then integration of, in place of sine square omega t, I'm going to write 1 minus cos 2 omega t upon 2, and the integration starts from 0 to t, and here I will write dt, then the final outside power is 1 upon 2, since it is square root, right? So now let me erase this one. Now in the next step I can write I naught square upon t. Now, so the integration for 1, then the integration of cos 2 omega t, right? So can I bring this 2 outside? I can write 2t, yes. So now here what I can do, so the integration of 1 will be t. Now integration of cos 2 omega t, which is equal to sine 2 omega t upon 2 omega, right? And this integration, the range is starting from 0 to t, and outside the power is 1 upon 2. Is it clear to all? Now the integration of 1 with respect to dt is t, and the integration of cos 2 omega t with respect to dt is sine 2 omega t upon 2 omega, right? Now in the next step I can write I naught square upon 2t. Then here one thing you can remember, so for this t, I will put once the value of t here minus, the steps for the integration. If you wish, I can write t minus 0. Finally, it will become t. So I'm not writing all this thing. So I'm writing only t, then minus. So once I will put t sine 2 omega t, right? Then it is divided by 2 omega, right? And later once again I will put the value 0. Of course the value will be 0. I'm not going to write for that. Then finally the power is 1 upon 2. I hope you got clear idea. So I have to put the value of t here in the place of small t. Then again I have to put the value of 0 there. If I put the value of 0, then all the multiplication will become 0, and sine 0 is 0, then all the things will be 0. So that is, I'm not going to write, but if you want you can write that, right? So now I naught square upon 2t into t minus, I'm writing sine 2 omega, then instead of this t, the time period, in oscillation, in circular motion, so the t is equal to 2 pi upon omega, right? So the t, time period, is 2 pi upon omega. So in place of this t, let me change the ink. In place of this t, I can write, what I can write? 2 pi upon omega, right? So this is the value of angle. Okay, so I'm not writing. Yeah, you can understand this is the value of angle. Then divided by 2 omega, then the bracket closed, then outside the power is 1 upon 2. Got the point? Now you can see here, I can cancel this omega and omega, right? So if I cancel, then it is becoming what? 2 times 2 pi, 4 pi. 4 pi means, 2 cycle it completes. Then sine 4 pi, its value is becoming 0. When 0 is divided by something, 0. Then finally, I can write I naught square upon 2t. So then it is multiplied by t, and these old values is becoming 0. So then outside power is half. Then now you can see I can cancel this t and this t, right? So then final answer I naught square upon 2 and its square root. Power is half means square root. So finally I can write I naught upon root 2. Okay, so this is the value. So I can write IRMS is I naught upon root 2. If I divide the reciprocal of root 2, the value will become 0.707 I naught. Okay, and of course this unit will be ampere, right? In the same way, if you want to find out the value of EMF, so the same process you have to use, because that EMF is also sinusoidal in nature, right? And in our household circuit, whatever the current, whatever the EMF we are getting, we are using, these all the values are RMS value, right? Now let us take some example and let us see its significance, okay?